Hi and welcome back to the Core Learning channel. Today I'm going to be going through the June 2023 Maths GCSE Higher Tier Paper 2, which is Calculator Aloud paper. I'm going to go through each question and show the methods I use to solve these questions. If you haven't already, please hit that like button and subscribe to our channel. This really helps us grow and reach more people, so your support really does help. Plus, if enough of you subscribe, I might actually get paid to do this. And with that, let's jump into our questions.
So for question 1, we have the ratio 30 to 12 in the form n to 1. So to do this, that is absolutely horribly done. We can divide top and bottom by 12. So 30 over 12 is 2.5, and then 12 over 12 is 1. So we have 2.5 to 1. For the next question, we have 4 consecutive triangular numbers are 6, 10, 15, and 21. So write down the next triangular number. So you'll notice for triangular numbers, the skip between successive numbers increases each time. I'll do that one down there. So plus 4, plus 5, plus 6. So the next one is going to be 21 plus 7, which is 28. Make that a little bit bigger. So write down the reciprocal of 4 over 7. Well, a reciprocal is just 1 over something. So 1 over 4 over 7, which is just 7 over 4. So for question 4, the price of a toy increases by 12.5% to £19.53. Work out the original price of the toy. So to do this, and I'm just going to do this on the other side, what we're basically saying is we have some value y, and when we add 0.125 of that value on, we get 19.53. So we can factorize this as y1 plus 0.125 equals 19.53. Well, this is going to be, so this is 1.125y equals 19.53, and therefore y equals 19.53 over 1.125, and this equals, and we'll put the pound sign in, £17.36. So for question 5, told that Jess saves 2p, 5p and 10p coins. She has 45 10p coins, 8 times as many 2p coins as 10p coins, and it's £17.70 in total. So the first thing we can do is work out the total value of 10p coins. So we have 45 times 10p equals £4.50. The next thing we know is that there are 8 times as many 2p coins as 10p coins. So if there are 45 10p coins, then this means there are 45 times 8 times 2p coins, which is 360 times 2p. So then what we need to know is work out the total value of 2p coins to total value of 5p coins. So we need to work out the total value of 5p coins. So we know that if we say, let's say the number of 5p coins is y, so this then becomes, we'll say y times 5p plus 45 times 10p, which we already know the value to, which is £4.50, plus times 360 times 2p. Well, 360 times 2p, what is that? That is going to be equal to £7.20. And all of this equals £17.70. So what this boils down to is that y times 5p equals £17.70 minus £4.50 minus £7.20. And if you work this out, this is going to come to, well, £4.50 plus £7.20 is £11.70. So this is going to come to £6. And that means that y equals £6 over 5p, which is going to be 200. So y equals 200. So then the total value of 2p coins is, and our final answer is £7.20 to £6, or 7.2 to 6. So ideally, when we're writing a ratio, we want both values to be whole numbers. So is there something we can divide 7.2 and 6 by? Well, there is. There's multiple ways to do it, but one thing I can see is that you can divide both by 1.2. And when we do that, you get, well, 7.2 over 1.2 is equal to 6, and then 6 over 1.2, which looks a bit like 102, that is equal to 5. So the ratio is 6 to 5. You can also equally you could divide both sides by 6, in which case you'd have 1.2 to 1, but it's usually a little bit cleaner to write both numbers as whole numbers. So for question 6, and we have part of a regular polygon is shown, and we're assuming the polygon is an octagon. We want to work out the size of an exterior angle. Well, for an octagon, or any polygon, the sum of the exterior angles is going to be equal to 360 degrees. And if you think about why that is, by the time you've done a full rotation, you get back to where you've started, which is 360 degrees. So we know that it's an octagon, which means 8 sides, and therefore one angle is going to be equal to 360 degrees over 8, and this is 45 degrees. For part B, we're told that the polygon has more sides than an octagon. What does this mean about the size of an exterior angle? Well, all this means is instead of having an 8, it's going to be a number higher than 8. So if the number in the denominator increases, then that means the total size of the angle is going to decrease. So it's going to be less than the answer to part A. So moving on to question 7. So we're told that we have an ordinary fair 6-sided dice, and it's rolled. There is a fair spinner, which is shown, and the score is the dice number substituted into the expression on the spinner. So for this part, we just have to fill out all the possible scores. So we're just going to replace every instance of x with the value from the top row. So 2 times 1 is 2, 2 times 2 is 4, should be fairly simple. And then we have 3 times 1 is 3, 3 times 3 is 9, 12, 15, 18. And then we have x squared, 1 squared is 1, 2 squared is 4. And then for part B, a player wins the game if their score is 10 or more. Work out the probability that they win the game. So if we just go back up, if we just look at this table, where are the values which are equal to or greater than 10? Well, they exist in this section here, which I'm just drawing out. So how many values sit in there? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 values. And then what's the total space of all the different possibilities? Well, it's a 3 by 6 table, so 18. So it's going to be 8 out of 18, which if we divide both sides by 2, we get 4 out of 9. And I'm just going to leave that as a fraction. We're then told the game is played 711 times, so we're going to estimate the number of games that are won. Well, if each game has a 4 out of 9 probability of winning, then we just times the probability times the number of events, and that will give us the number of games we expect to win. So it's 4 over 9 times 711, and when we work this out, we get 316. So for question 8, we have a minus 3x squared plus 2b equals 5x squared plus 12. So here, we want to know what a and b are. Well, here we can just compare the coefficients. So we have that a minus 3 equals 5, and we have 2b, oh god, this pen is useless, 2b equals 12. So here we have, if we add 3 to both sides, we get that a is equal to 8, and we have that b is equal to 12 over 2, which is 6. So we have 8 and 6. So for question 9, we're given two coordinates, a and b, at 1, 3, 2, 9. and we're told that ABCD is a parallelogram, and we're told that AD and BC are horizontal and each has a length 5 centimeters. The diagonals of ABCD cross at E, and we want to know the two possible pairs of coordinates of E. So, just roughly, a parallelogram, as the name probably suggests, it's a shape where we have two pairs of parallel sides, and that's basically as far as it goes. So, I'll just draw this out. So if we have a length of 5, so I think it says that, yeah. So AD and BC both have a length of 5 centimeters. It doesn't specify in what direction, so that's why we can get two values for the midpoint. So let's just go in the positive x direction to start. So we go across there, we go across here, and then let's see if we can get, don't know if we can get a straight line. No, we don't want that. No, that's fine. Okay, I'll just have to draw not very well. So apologies, these are meant to be straight lines. So that's going to be our first shape, and then if we are to go -5 in each direction, so and another 5, and again we'll join these up. So these are two shapes, and then the midpoint is just going to be where two sets of cross-sectional lines meet. And whilst I know that I haven't used straight lines, you can hopefully see that the points that are meant to be shown are, well, let's go for the left-hand side first. So the left-hand side has an x value of -1, and -1, and then y is 6. And then on the other one, y is 6 as well, but x is 4. So we have -1, 6 and 4, 6 as the two possible pairs of the coordinates of E. So for question 10, we're asked to write down the translation vector that maps shape A onto shape B. So we write this in the form of these brackets, and then the top value is going to be the number of units moved in the positive x direction. So to get from A to B, we go 1, 2, 3, 4. So we move 4 units in the x direction, and then we move 1, 2, 3 in the -y direction. So the translation is 4 minus 3. So for question 11, and we're given the volume of a sphere, and we're told a bowl is a hemisphere with radius 12 centimeters. Water is poured into the bowl at a rate of 325 centimeters cubed per second for 8 seconds. We're asked, does the water fill more than 70% of the bowl? So first things first, and actually let's go ahead and do this on the other page. So the total volume of the bowl, so let's just call it volume total, is equal to, well, it's a hemisphere, so it's going to be the volume of a sphere divided by 2. So we're going to have a half times 4/3 pi r cubed. And we know that r is 12 centimeters, so we're going to have 4/6. What's 4/6? That's equal to 2/3. So 2/3 pi, and then 12 centimeters cubed. And then when we work this out, this comes to 1,152 pi centimeters cubed. Next, we want to work out the total volume of water poured into the bowl. So if something's poured at 325 centimeters cubed per second, this means what it says, every single second 325 centimeters cubed of volume is going into the bowl. So if it goes for 8 seconds, then we just do 325 multiplied by 8, and this gives us 2,600 centimeters cubed. So this is how much is going into the bowl. So the question is, does the water fill more than 70% of the bowl? So what is 70% of the total volume of the bowl? Well, it's going to be equal to, and in fact, actually, it's going to be equal to 0.7 times the total volume, which is 1,152 pi centimeters cubed. and this gives us 2,533.4 centimeters cubed. So does it fill more than 70% of the bowl? Well, we can see that 2,600 is greater than 2,533.4. So let's just make that explicit. So yes, it does. I'll just write yes here. For question 12, we're asked to show that the two rectangles are similar. What does it mean by similar? Well, there's a number of different things, but essentially, for a similar rectangle, the ratios between the width and the length should be the same. So there's a number of ways we can do this, but we can either compare the ratio between the widths of each rectangle or the height of each rectangle, or just for each one individually, we can work out the ratio between the width and the height. So let's go with that approach. So what we should have is that 12 over 5 is equal to 19.2 over 8. So if we just work this out on the calculator, 19.2 over 8 is in fact equal to 12 over 5. So they are the same. They do have the same ratio, which means they are similar. For question 13, we're told that the factory packs X boxes of tea bags per hour, and each box contains 80 tea bags. So we want to show that the factory packs 4x over 3 tea bags per minute. So the first question is, how many tea bags are being packed per hour? So if we have X boxes and each box contains 80 tea bags, then it's 80x tea bags per hour. And if we want to work out a minute, well, a minute is an hour divided by 60. So it's going to be 80x over 60. Well, we can divide top and bottom by 10, and we get 8 over 6. And then we divide top and bottom by 2, and we get 4 over 3x tea bags per minute. So for question 14, we're told that a company has 123 employees. We're given this information about their hourly rates of pay in the form of a frequency table. And we have some statements. And the first one says that over 30% of employees have an hourly rate that is more than £17. And we want to show some working that supports statement A. So over 30% of employees have an hourly rate that is more than £17. Well, one way we can do this is if we say that each incremental value between, in this bracket here, each equal incremental bracket, i.e. £14, £15, £16, £20, though it won't be £20 because it's less than 20, up to 19. What we're saying is each value is represented by an equal number of people from the number of employees with that in that range. So basically what we're saying is each value would have 32 over 6, would it be? 32 over 6. Or in fact, the easiest way to do it is if we have 14, 15, 16, which is obviously below the £17 hourly rate, and then we have 17, 18, 19, we can actually just do 32 over 2, which is 16, and that means that we have 16, so we have 16 below the £17 mark, and we have 16 above the £17 mark. And if we were to do it like that, then we could say that we have, obviously, in these two boxes here, these are all above 17. So in that case, we'd have 10 plus 15 plus, and then we're saying that there are 16 employees over on £17 an hour or more, plus 16 out of 123 is equal to, well, this is going to be equal to 41 out of 123. And that is equal to a third. So that's equal to 1 over 3, which we know is 33.3%, which is greater than 30%. So this would support statement A. So part B, why might statement A not be true? Well, the way we've used to work it out might not be true. It might not be true that there are 16 people in that bracket on £17 an hour or above. It might be the case that of the 32 people in that bracket, 30 are below £17 an hour and only 2 are on £17 an hour or above. So, yeah, what should we put for this? Why might statement A not be true? There could be more people on I apologise for my handwriting. So for part C, work out an estimate of the mean to support statement B. So one way we can do this, if we go back to our table, and let me just actually, oh no, that's not what I meant to do. Let's just erase some of this. Yep. So one thing we can do to estimate the mean is that we can just take the midpoint of each frequency bracket and then multiply it by the number of employees in each bracket and then divide by the total. What I mean by that, so I can just go and do it on this side. So what we'd have is, for the first bracket, so 10 to 14, we'd say that the midpoint is 12, and we multiply that by 66. And then we take the next one, which is 14 to 20. So the midpoint is 17 times 32. And then we have 20 to 40, so the midpoint is 30 times 15. Plus, and then lastly, the midpoint is 70 times 10. And all that would be over 123. And when we work that out, that gives us 2,486 over 123, which is equal to £20.20. So this is a value of the average that we can work out. So £20.20 equals, I'll just call it X for the mean. Statement B says the average hourly rate of pay is more than £20. Well, yep, that's what that shows. That shows that it's more than £20. But if we go on to part D, it says, why is the mean not the best average to represent the data? Well, because if we look, you can see that the data is heavily skewed, i.e., if we look at the first two alone, we have 66 plus 32. We have 98 employees on less than £20. 98 out of 123 on less than £20. So we only actually have a few on more or significantly more than the £20 quote-unquote average, but that's heavily skewing the data up, but it doesn't actually represent an equal sort of number of employees in each bracket. So this isn't really a good way to conduct the mean. So yeah, so many more employees below £20 an hour than above. So for part 15, we're asked to expand x squared minus 9xy to x plus 5y. Okay, so when we're expanding, we just need to make sure we consider multiplying each element by each other element. So if we start with x squared times 2x, we get 2x cubed, and then we do the x squared times 5y, and we get plus 5x squared y. And then we're going to do the minus 9xy times 2x, so we get minus, well, 9 times 2 is 18. And then we have 2x's, so we have x squared, and then we have a y on the end. And then lastly, we have to do the minus 9xy times 5y. So minus 9 times 5 is minus 45. And then we have only one x term, and then we have two y terms, so that's y squared. So let's simplify. So we've got our 2x cubed, and then we can see we need to always compare like terms. Now, just be careful, we have two lots of x squared y terms, but just be careful, this last term is xy squared, not x squared y, so we leave this by itself. So in that case, well, plus 5 minus 18 is minus 13 x squared y, and then minus 45 xy squared. So moving on to question 16. We're told that line A has equation y equals ax minus 1, and it passes through the point 7, 13, and line B has equation 5y minus 3x equals 4. We want to show that line A has a greater gradient than line B. Let's remember that the equation of a line is given by y equals mx plus c, where m is the gradient. So we can work out the value of a first of all, and again let me just do this on the other side. So we have y equals ax minus 1, but we know that 0.713 goes through this line. So if we substitute those values in, so y equals 13, and then we have a times x, which is 7, minus 1. If we rearrange, we have that, just delete that, we have that 7a is equal to 14, and therefore a equals 2. So we now know the gradient of line A is 2. So now, if we rearrange line B, so we have 5y minus 3x equals 4. And let's get this in the format y equals mx plus c. So we have 5y equals 3x plus 4. And then we have that y is equal to 3 over 5x plus 4 over 5. So this means that the gradient here is equal to 3/5. So going back to our question, does the gradient of line A, or should I say, is the gradient of line A greater than the gradient of line B? Well, what we're asking is 2 greater than 3/5? Yes, it is. So, yeah. So moving on to question 17. We're told to work out the size of angle x. So I think this is going to be a contender for some trigonometry. So let's just label our sides first. So if we treat these as two separate right angle triangles, we have the angle, or I should say the side opposite the right angle is the hypotenuse. The side opposite the angle is the opposite side, and then we have the adjacent side, and we just got to be careful here. So I'm only referring to this triangle on the right hand side right now. If we go to the left hand side, this is going to be our hypotenuse. The angle here, however, x, points here, so we've got to be careful. The straight line coming down, it's an adjacent for the right hand triangle, but it's an opposite for the left hand triangle, and then the last side is going to be our adjacent. So starting with the right hand side, if we use our SOHCAHTOA, you'll remember that, and what we want to work out, sorry, I should say, is this adjacent side. So we know SOHCAHTOA, ka, which is cos of angle, which is 37 degrees, equals ka, which is AH, equals adjacent over hypotenuse, which in this case is equal to, well, it's just going to be adjacent over 4 centimeters. So we know that the adjacent side is going to be equal to 4 times cos 37 degrees. And when we work this out, we get 3.19 centimeters. So let's just label this side as 3.19 centimeters. So now we have, for this left-hand triangle, we have the opposite side, we have the hypotenuse, and therefore we can use sine of x. So remember, SOHCAHTOA So we have sine of x equals opposite over hypotenuse, which equals 3.19 centimeters over 9.3 centimeters. And we just get rid of the centimeters, it doesn't matter. So the way we go about working this out is we have to take the sine to the -1 of both sides. So sine to the -1 of, and 3.19 over 9.3, sorry, I should say, is 0.34. So sine to the -1 of 0.34 is equal to x. And just so you know, the reason for that is that we applied sine to the -1 of both sides. So sine to the -1 of sine of x, these two cancel out, so you're just left with x. So when we do this in our calculator, we get that x is equal to 20.1 degrees. Moving on to question 18, and we want to make x the subject of this equation. So the way we can go about doing this is, let's start off by multiplying both sides by x, which gives us that yx equals x plus 8. And then we can now get x on both sides. So if we subtract x from both sides, we get y of x, or I should say yx minus x equals 8. We can then factorize, so we have x y minus 1 equals 8. And so our answer is that x, and then if we divide both sides by y minus 1, I'll just do that. So if we divide both sides by y minus 1, then we just cancel on this side, and we get that x is equal to 8 over y minus 1. So for question 19, we're given the first 4 terms of a quadratic sequence, and we're asked to write an expression for the nth term of the sequence. So as a rule, the expression for the nth term is going to be given like this. It's going to be a n squared plus bn plus c, where n is obviously the nth term, and then a, b, and c are to be determined. So what we can do here, and we can check it's quadratic because the second difference should be consistent. What do I mean by that? Well, let's just write out our numbers: 3, 20, 47, and 84. The first difference, well, here we have 17, 27, and then 37. So the first difference here, you can see it's not the same. It's different between each set. But if we work out these differences between the differences, so this is the second lot of differences, then you can see it's just, and obviously I haven't gone that far, but it's just going to be plus 10 every time. So this tells us that it is definitely a quadratic sequence. And as a rule, and it can be proven as well, but as a rule, what we know about a quadratic sequence is that this term a here, we know that 2a is equal to this difference. So it's going to be 2a is equal to 10. So whatever this difference was here, if it was 15, it would be 2a equals 15. If it was 20, 2a equals 20. So this allows us to work out the value of a. So a is going to be 10 over 2, which is 5. So let's just plug that in. So we now have 5n squared plus bn plus c. So now we just need to work out the b and the c. So the way we can go about doing this is, let's work out our first term. So we know that t of 1, i.e. t of when n is 1, which is here, we know this is equal to 3, but if we just fill this in, we have 5 times 1 squared, because remember this is the first term, so we substitute a 1 in wherever we have an n, plus b times 1 plus c equals 3. And then if we have our second term, and what I'm looking to do here to solve b and c is to create a pair of simultaneous equations. So for t2, and in fact, actually, I'm being an absolute idiot because I didn't actually fully simplify this. So we have b plus c is equal to, well, 5 times 1 squared is 5. So if we subtract 5 from both sides, it's going to be b plus c is equal to 3 minus 5, which is minus 2. And then if we work out our second term, we have 5 times 2 squared plus b times 2 plus c equals our second term, which is 20. And if we simplify this, we get, well, 5 times 2 squared, that's 5 times 4, so we have 20, plus 2b plus c equals 20. Well, if we subtract 20 from both sides, we get 2b plus c equals 0. And what this actually tells us also is that c is equal to minus 2b. So we can actually substitute this in, and we get that, and I'm just going to write this on the other side, we get that t of n equals 5n squared plus bn minus 2b, which if we simplify, well, we have plus b n minus 2 and then if we do t of 3 with our new expression, so we have 5 times 3 squared plus b 3 minus 2, because it's n minus 2, and that equals 47. And now we just have one value to solve, which is b. So here we're going to have, if we simplify, 5 times 3 squared, that's 5 times 9, that's 45, plus, well, 3 minus 2 is just 1, so 45 plus b equals 47. I'm sure we can see there that b is therefore, b is equal to 2. And using this, we can also work out c. So, and in fact, just because I'm running out of room, I'm just going to continue on the right-hand side. So if we use our other expression, and again, it doesn't matter which one we use, we just need an equation to work out c. We can use t1, t2, t of 3. So if we do t of, we'll just go for t of 3. So, and again, we have 5 times 3 squared plus, plus b plus 2 plus c. And in fact, sorry, it's not plus b, it's plus b of n. So let me just go back. So plus 2n, because remember b is 2, so instead of b I've just replaced it with 2, plus c equals 47. So we have 45, which is the 5 times 3 squared, plus, in fact, I don't know why I wrote n in, because we know that n is 3. So we have 45 plus 6 plus c equals 47. And just simplify that, so we have 51 plus c equals 47. So this must mean that c is equal to, well, if we subtract 51 from both sides, then that must mean that c is equal to minus 4. So our final expression, which translates the nth term to the value, is given by 5n squared plus 2n, and then plus c, which is just minus 4. And you can obviously go back and check this. So, you know, plug in the value of 1, and let's just do this actually. If we plug 1 into this equation, 5 times 1 squared is 5, plus 2 times 1 is 7, minus 4, I did not mean to do that, minus 4 gives us 3. And if we do the same thing with 2, 5 times 2 squared is 20, plus 2 times 2 is 24, minus 4 is 20. And for 3, 5 times 3 squared is going to be 45, plus 2 times 3, which is 6, which is 51, minus 4 is 47. So you can see for the first 3 times it works. You can obviously go and check the last one as well. It will work. So moving on to question 20. And we're told that these 3 points P, Q, and R are on a circle, and that S is a point inside triangle PQR. And we want to assume that S is the center of the circle. What is the side of angle X? So, and I'm completely blanking on the name of the rule, but basically when we have this set up, we know the relationship between these two angles is that angle X is going to be half of this angle below. So X is going to be 130 divided by 2. So X is 65 degrees. Now, we're told, I'm just going to get rid of that. We are told that the center of the circle is on this line, PS, but not at S. So what does this mean about the size of angle X? Well, what does it mean about the size of this angle below S? Well, quite simply put, if we move where the point, the center is, then we have to either decrease one or more of the two angles here. If you think about it, you know, if we were to move it to this point, say, we would have a narrower angle. Whatever we do, wherever it is, it doesn't matter. You have to decrease the overall sum of these two angles at P and R. If that's the case, then that means the angle at S increases, because we know, oh my god, this eraser is terrible. I'm just gonna leave it. Obviously, we know that the total angles in a triangle is 180 degrees. Therefore, if we say that one or more of the angles has to decrease in size, then it means the other angle has to get bigger. If that angle gets bigger, and we know that X is half of that angle, then that means that X has to be bigger. So that means that X will be greater than it was to the answer in part A. So for part C, we're given a different circle. We're told that AB is tangent to A, C and D are on the circumference of the circle, and AC equals CD. Simon wants to use a method to work out the size of angle Y, and he says, using the alternate segment theorem, ADC is equal to 70 degrees, therefore Y is equal to 70 degrees. Well, is he correct? So what does the alternate segment theorem say? The alternate segment theorem says that when we have a line which is tangent to a circle, the angle between this tangent and a chord on the circle, so a chord is just something that goes between 2 points on a circle, the angle is equal to the angle here. So actually, this angle up here is going to be equal to 70 degrees according to the alternate segment theorem. Now, the other thing to note here is that the sides AC and CD are equal, as you can see up here. What this means is we have an isosceles triangle. So if we have two equal sides, then this is also going to be equal to angle Y. So the actual value of Y is going to be equal to 180 degrees minus 70 degrees, and then over 2, because they're both angle Y. So in this case, angle Y is actually going to be 55 degrees. So Simon is wrong. So for question 21, we're told that Magana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. And we've got to work out to one decimal place the minimum annual interest rate she needs. So what this is asking is, if we call the interest rate Y, this is saying 500 times Y cubed. Oh my god, that was absolutely appalling. So the only thing about using some of these apps is that they're not great to draw on. So this has to equal, as a minimum, 560, and we want to work out what Y is. So we know that Y cubed is equal to 560 over 500, which is equal, with a quick calculation, to 1.12. Therefore, if we take the cube root of both sides, well, if we take the cube root of this side, we just get Y. So Y is equal to the cube root of 1.12. And when we work this out, we get that Y is equal to 1.038. So what this means is that you have an interest rate of, well, obviously it's 1.038, but if we're going to work this out as a percentage, then it's increasing by, if we subtract 1, we get 0.038, and then we times by 100, and this gives us 3.8%. So the answer is that it needs to be increasing. Sorry, the answer is that the minimum annual interest rate is going to have to be 3.8% for these conditions to be met. So moving on to question 22, and we're given this iterative formula that can find an approximate value of the root of an equation. We're told that the starting value is x1 equals 4, and we've got to work out the values of x2 and x3. So I'm going to go ahead and do this on the right-hand side. So let me just write this down, x1 equals 4. So x2 means that n equals 1, because it's xn plus 1. So for x2, every time we see x of n is going to be x of 1. So we have the cube root of 5 times x of n, which is 4, squared, minus 2 times x of n, which again is 4, minus 3. And let's just get rid of this. This is therefore going to be equal to, with a quick calculation, it's going to be equal to it's going to be equal to 4.1. And then we're going to work out x3. So for x3, every time we see xn, it's going to be x2. So we have cube root of 5 times 4.1 squared minus 2 times 4.1 minus 3. And when we work that out, I get that to be 4.17. So for this part A, we have 4.1 and 4.17. And for part B, we're asked that by continuing the iteration, show the value of x is more than 4.25. So if we just carry this on, we can go for x4, and we have 5 times 4.17 squared minus 2 times 4.17 minus 3. And that is equal to 4.23 by my estimation. Now, a handy little trick for this when you're using your calculator. Set the answer equal to x1 at the very start. So I did something like 4 times 1 equals, and then it's going to be 4. And what that means is in your calculator, the button answer, ANS, is now stored as 4. And then you just have to set up your equation. So set up the formula. So the cube root of 5 times answer squared minus 2 times answer minus 3. And then every time you click, it will update the answer with the answer. So you click it once, it will give you your x2. You click it again, it will give you your x3. You click it again, it will give you your x4, and so on. And it just means you don't have to keep typing in a value. So it's just a little trick to do that. So to get our x5, which hopefully, I think this might take us over the 4.25. So we have 5 times 4.23 squared minus 2 times 4. Why is that not wrong properly? 4.23 minus 3, and that gives us 4.28, which is greater than 4.25. So that answers part B. Moving on to question 23, we're given 3 sets of cards, and we're told that a player has 2 options in this game. They can either pick 2 cards from set A or a card from set B and C. The cards are picked at random, and the player wins if the total of their 2 cards is exactly 10. So what we need to do here is see the number of ways. Oh, in fact, actually, it would help if we read the question. So which option gives a better chance of winning, option 1 or 2? So what we need to do here is see how many ways we can win using the option 1 approach and how many ways we can win using the option 2 approach. So how many ways can we get a 10 using just set A? And again, I'll write this on the right hand side. Well, I'm looking at it and I think actually you'd have to draw 2 5s. So the probability of drawing that first 5 from set A, well, there are 3 5s and there are 8 cards. So say the probability of 10, and let's just say 10, 10A. So the probability of a 10 from A on the first go is equal to 3/8. And then on the second go, bearing in mind this card is now left, and that's the key thing to remember, this card has now left the pack. The probability of, in fact that's wrong, it shouldn't be the probability of a 10, it's the probability of getting a 5 is what we're interested in. So the probability of getting a 5 from set A is 3/8. The probability of getting a second 5, well, there are now, presuming you've taken the first 5, it will now be, there are now 2 5s left, and there'll only be 7 cards. So the probability of getting a 10 combined from set A is going to be 3/8 times 2/7, and that gives 6 out of 56. And if we divide top and bottom by 2, that's going to give us 3/28. And now if we use the same approach for set B and C, I'm looking at it and I think the only way you can do it is if you get a 4 in set B and a 6 in set C, or a 6 in set B and a 4 in set C. So it either has to be this, or it has to, no, not that. That will not allow you to win. Or this. So what we have to work out, what is the probability of, I'll just move this up slightly. What is the probability of drawing a 4 from set B? Let's just write out the full equation. It'll be the probability of getting a 4 from set B. No, that's not right. We're combining probabilities, so it'll be times the probability of getting a 6 from set C plus the probability of getting a 6 from set B times the probability of getting a 4 from set C. So the probability of getting a 4 from set B, well, there are 8 cards. Are there 8 cards? No, there are 7 cards, and there's only 1 4. So it's 1 in 7 times, I should put some brackets around it. And then what's the probability of getting a 6 from set C? Well, it's only going to be, there's only 1 6 and there's only 4 cards, so it's 1 in 4. And then we add, what's the probability of getting a 6 from set B? Well, again, there's only 1 6 and there's 7 cards, so it's going to be 1/7 times, and then again, there is only 1 4 in set C and there are 4 cards, so it's 1 in 4. So when we work this out, it's going to be 1/28 plus 1/28, which is 2/28. And what this means is we have, for picking cards just from set A, so actually let's just write this out explicitly. So option 1, probability that you win is 3/28. Option 2, the probability that you win is 2/28. So you have a higher chance of winning using option 1. Moving on to question 24, and we're told that A is 65 to the nearest integer, and B is 30 to one significant figure, and we need to work out the upper bound for 2a squared minus b. Well, what we want to do here is work out, we want A to be as large as possible and B to be as small as possible. So let's set A equal to 65.5, and we'll set B equal to, well, if it's one significant figure, then we can actually set B to be 25. And if we substitute those values in, we have 2 times 65.5 squared minus 25 squared. And if we work that out, that gives us 7,955.5. So moving on to question 25 even. And yeah, we're given this equation and we want to show that it simplifies to ax squared minus b over x squared minus 4. So how do we go about doing this? And again, I'm going to do this on the right hand side. So we've got x minus 5 over x minus 2 plus x plus 5 over x plus 2. So what I'm going to do is I'm going to try and get the denominators to be the same. So to do this, I want the denominators on each side to be x minus 2, x plus 2. So I'm going to multiply top and bottom on the left-hand side by x plus 2. And then on the other side, I'm going to multiply top and bottom by x minus 2. And now we can see that the denominator on each side is equal to x plus 2, x minus 2, which means we can combine the numerators. So we now have x minus 5, x plus 2, plus x plus 5, x minus 2, over x minus 2, x plus 2. And then we just simplify the top. So this is all we need to do. And I won't go into huge detail. I'm just going to go through the answer. So this is going to give us x squared minus 5x plus 2x minus 10 plus x squared plus 5x minus 2x minus 10 over x minus 2x plus 2. X. So that gives us 2x squared. We've got minus 5x and plus 5x, so they cancel. We have a plus 2x and a minus 2x, so they cancel. So we're left with 2x squared minus 20 over x minus 2, x plus 2. And if we simplify further, we get 2x squared minus 20 over x squared minus 2x plus 2x, which is 0 minus 4, which is what we were looking for. So this means that a is equal to 20 and b is equal to, my apologies, that's not correct. What that means is that a is equal to 2 and b is equal to 20. So moving on to our last question, and we have this sketch of a y equals x squared graph, and we are told that the minimum point of this is at 0, 0, and then we're told to write down the coordinates of the minimum point of y equals x squared plus 2. Well, all this is going to mean is that whatever value we originally had of y is just 2 more, so it's just going to shift the graph up by 2 in the y direction. So I'll just write y. So it's just going to shift the graph up by 2 in the y direction. So what that means is when we have our x coordinate is going to change. It's going to be 0, but it just means when y is 0, y is now going to be 2. Moving on to part B, the graph y equals x squared is reflected in the x-axis. Write down the equation of the graph after this transformation. It's just going to be y is equal to minus x squared. So you've got to think, if you've got the graph like this, oh my god, my drawing skills are leaving a lot to be desired. All you've got to think is, whatever value you originally had of y, it's now just going to be opposite. So when y is, say, for instance, I don't know, 2, it's now just going to be equal to minus 2. So it's y equals minus of x squared. And lastly, we have y equals x squared is now transformed to give y equals x plus 3 squared. And we're asked to describe fully this single transformation. So I think we've already done one before, but we've got the brackets again. And if we think about this, y equals x plus 3 squared. So now, say for instance when x was 0, x is now going to be where x at 0, when x is 0, it's now going to be the same as when x was 3. So let's actually just draw this on the other side. So we'll just mark the graph. Why is this pen not working? So this is our original graph. And we've got our y-axis, our x-axis. So now let's say let's call this x equals 3, right? So what we're going to say is, when x used to be 0, y was 0, wasn't it? But now, when x is 0, y is going to be 0 plus 3 squared, which is 9. So y is going to be 9. So now, when x is 0, y is going to be equal to 9, isn't it? So the graph actually is shifted to the left. So ignoring everything else, if we have these two shapes, what we're saying is to go from the original, where it goes through this point 0, 0, to get to the one on the left, well, in the y direction, nothing happens, does it? It doesn't change with regards to y. But for x, it is -3. It goes to the left, doesn't it? It goes in the -3. It goes -3 in the x direction.
So, thanks for watching, guys. Hopefully you found that useful. If you have any questions, or even just feedback for how this could be more helpful, leave a comment and I'll get back to you as soon as possible. If you haven't already, hit that like button and subscribe to our channel. As I said at the start, this really will help us grow, so your support is really appreciated. With that said, all the best, guys, and I'll see you at the next one.